So let's talk about the three big graph questions. Every time you look at a graph, it has an awful lot of meaning embedded in it. And there are a lot of things you can ask in order to go and dig out this meaning. But for the very beginning, I want you to start by always asking the three same questions every time you look at a graph of data. Those three questions are: 1, is there a relationship between these two quantities? 2, is it a direct or an indirect relationship? And 3, is the relationship linear or is it not linear? Now, before we talk about these, I just want to say a quick thing about data. It's really important to remember that data is messy. The points don't necessarily all line up. In math class, you may look at a graph and it's like, oh, everything is all perfect. But in science, especially in physics, or at least in this physics class, data comes from making measurements in the world. And it's not that we say like, oh, I made a mistake with that. It's just, it's hard to measure very precisely. It's hard to know exactly what you're measuring. Things jiggle around. So as soon as you start graphing real honest to goodness data, it probably doesn't look all clean and pretty. It probably looks a little more like this data. And the reason I'm bringing that up is it's important to remember that when we're asking these questions, we're trying to ask about the big picture. We're not asking about any individual data point. We're not saying like, oh, wait, here it went down, wait, and then it went up, and then it went down again. We're trying to look at the whole pattern as if all of these data points sort of were one big, blob. Like, what is the shape of the overall pattern that the data makes? So first, let's talk about the first question. Is there a relationship between these two quantities? Another way of asking that is to say, if one of these quantities changes, does that cause a change in the other quantity? Does one of these quantities influence the other one? Or alternatively, are these two quantities unrelated? So let's look at that question in action. Here's a graph. Is there a relationship between these two quantities? Well, let's look at what happens when x is a small number. When x is a small number, y is also a small number. That's these points down here. It's hey, can I mark this up? Oh, I bet. A pen. Down here, when we have small x, we also have small y. And up here, when we have a big value of x, it's connected to a big value of y. So when x goes big, y goes big. So we would say these two are related. How about this one? Now, this is more like that sort of messy data that I was talking about. And it's important to remember that what we care about is the overall pattern. The overall pattern. We're not looking at any individual points. We look at this like, is there an overall trend? Now, one thing that's troubling here is notice this scale doesn't actually start at 0. And that should bother us. Hang on a minute. Do I have a version of this one? Yeah, here it is, right? So one thing that we could do with this graph is we could say, hey, let's make this scale start at 0. And if we do that, we're going to have a better look at this data. So notice now our scale both starts at 0. Small x, small y. Big X, big Y. Okay, is there a relationship? Yes, there is a relationship. How about this one? Is there a relationship? Well, notice again we have this problem of this should start at 0, right? Should start at 0. But it doesn't start at 0. So the question is, small x, well, lots of different y's. Large X, also lots of different Y's. I would say that there really isn't a relationship here. The overall trend is not up and it's not down. They're just points all over the place. So these are unrelated quantities, and that happens all the time. Sometimes you measure two things and they are not influencing each other. X and Y in this case are independent. So that's our first question. Is there a relationship between the two quantities? When we change one, is the other one going to change? Oh, maybe I should look at this one with a proper scale. Do I have it here? Oh, there it is. Look, we set this to a proper scale. Let's make that 0. 0, boom. Oh, look. And the thing to notice here is that, notice that small x, y is around 40. Middle x, y is around 40. Big X, y is around 40. Y is just not changing when we change x. Question number 2. Is this relationship, and we only ask this if the answer to the first one is yes, is this relationship a direct relationship or an indirect relationship? And one way of thinking about that is, does an increase in one quantity cause the other quantity to increase? Or alternatively, does increase in one quantity cause the other quantity to decrease? Let's look at some examples. Okay. Here, small x, small y, big X, big Y. So in this situation, we have an overall trend that way. Increase in x is associated with increase in y. This is called a direct relationship. This is a direct relationship. Over here, we see that as x gets bigger, right, here's small x, and here's big X. As x gets bigger, y gets smaller. We have this downward trend. We have a downward trend. This is called an indirect relationship. Any kind of downward trend where bigger x makes for smaller y, that's an indirect relationship. And this one is a direct relationship. Another way of thinking about this is that the overall slope of this pattern is positive. And the overall slope of this pattern is negative. And again, sure, do they go up and down? The points go up and down and up and down, but the overall trend is down, and here the overall trend is up. Is this direct or indirect? We go from low to high. That's direct. Is it direct or indirect? We go from high to low. That's indirect. Last question. Is the relationship linear or is it not linear? This question is much trickier than it looks. People get tempted to answer this in all sorts of ways that really aren't about whether something's linear. Okay, so I want you to be really careful. This is an example of something that's really not particularly intuitive. It just doesn't seem like it is the way it ought to seem. But once you practice it a bunch, it starts to make sense. Is the relationship linear or not linear? Here's how we figure out. Let's say we have some data. Is it linear or is it not linear? Well, what we're going to do is we're going to draw a line through the data. You would ask your graphing program, I'm going to do with Logger Pro, to draw a best fit line. So like I might go to Logger Pro. Where is that? I bet I can find that graph. Looks like that. Yeah, it looks like that. So here I am in Logger Pro, and I'm going to go up here to this button that says linear fit, and I'm going to click on it. And I'm just going to hide this little thing. I'm going to click on it, and it draws a line that comes as close as possible to as many points as possible. What does that mean, though? What do we do with that line? The thing that's important to remember is that when we draw that best fit line, it's a test. It's not a statement. The line doesn't say, this is linear, because you know what? You can draw a line through anything you want. The best fit line is going to help us make a test. So what is the test that we do? Let's look. So first, we're going to look at all of the points that are above the line and just locate them. Now here I've colored them purple, but and if you had a piece of paper, you could mark them up, or you could just sort of imagine that all the above the line points were one color. And then we're going to go and we're going to look at all the points that are below the line. And here I've colored them green. And again, you can do this in your imagination, or you can mark something up with crayon. Anyway, where are the points that are below the line? So once you've done that, here's the test. Are the above and below points spread out I don't want to say, I was about to say evenly. We're not looking for even spread, but are they spread out, or do they clump up in the middle or in the ends? Before we answer about this, I want to show you a different graph, okay? I want to show you a graph for comparison. So let's say we have this graph, all right, and we draw a line through it, okay? I go and I get Logger Pro to put in a best fit line, and now I'm going to count the aboves and belows, and I get this. And we ask, are the points evenly spread out, or do the above and belows clump in the middle or the ends? Let's compare these two graphs. So the one on the left, as you can see, the aboves and belows pretty much spread out. I mean, there's some gaps and things, but it's how they're arranged around the line is pretty much random. They're just spread around. Whereas the one on the right has clumps. It has a pattern. The belows are at the ends, and the aboves are in the middle. If the points are spread out, we say that this is linear. Okay, we say that this is linear if they're evenly spread out like that or sort of randomly arranged. Whereas here, because there's this pattern, because the belows are at the ends and the aboves are in the middle, this is not linear. It's probably data that would be better fit with some kind of curve. And, you might think that you can just eyeball a graph and just be like, oh, that one's curved and that one's a straight line. But it's actually really hard to do unless you actually draw the line and look at where are the aboves and where are the belows. So here, where we've got the aboves in the middle and the belows at the end, we say this is not linear. Okay? So that's the deal. Let me go back here. If the aboves and belows are evenly spread out around a best fit line, we say that's linear. And if the aboves and belows are clumped in the middle or at the ends, this is not linear. And that's how you make that decision. People often are tempted to make lots of other think about this in lots of other ways. And I just want to show you another set of comparisons. So let's look at these three graphs. Sometimes people might look at this graph here and go well, it's really messy. The points are, all over the place. This is not linear. Whereas here, the points are really clean. This one is linear. It's important to remember that the test of whether something is linear is not, is it messy or is it clean? The test of whether something is linear is where are the points? And here, look, the belows, they're spread all over. And the aboves, they're spread all over. This is just as linear as that. It's just messier data. It might be that this is something where the measurements are just harder to take. So this is not a question of, are the points close to the line? It's not a question of going around and counting how many above and how many are below. Both of those things do not test whether something is linear. The test of whether something is linear is this. Do the aboves and belows clump, or are the aboves and belows spread out? Okay, those are the three graph questions. Here, we'll just go back to the beginning. What are the three graph questions? The three graph questions are, is there a relationship? Is it a direct relationship or an indirect relationship? And 3, is the relationship linear or not linear? Okay.